Hi team, this is Chris Abraham from GOHmath. Today we're going to look at number 17 on the 53 Math MTEL practice exam. First, I want to read it over. Which of the following equations represents a valid algorithm? And then it gives me these right here. You know what? If it was that easy, then I wouldn't be doing these videos. But there's more to this than just read it over and solve it. First, you got to slow down. When I read this over, I notice there's really not much here. It's just a one-liner. So what is here? Well, what can we learn from this problem? First of all, it has the word equation. Remember, it's when two values are connected by an equal sign. This is an equation. 2 plus 3 equals 5. Right? Okay, so we're getting an idea of what an equation is. These are a little bit more complicated, but they're equations. This value here, we're trying to find out if which one of these values is which one of these equations is accurate. So when I do this, does it equal this? Only one of these work. Alright, so that's a review of an equation. If it was no equal sign, it would just be an expression. Okay, so we get a little review of vocabulary. What about algorithm? What's an algorithm? An algorithm, think about it this way, team. An algorithm is a way of doing something. Just like, I did 2 plus 3 equals 5, I could have easily have done 2 plus 3 this way equals 5. Or I could have represented it as 2 plus 3 equals 5. Algorithm is just a fancy way of saying a way. Alright? Okay, so we've learned a little bit just by pulling apart the actual one-liner here. Now I'm looking for the way that is accurate. So 3 of these are incorrect. One of them is correct. Now before I find out which one is correct and the ones that are not correct, let's examine what the skill is that I'm doing. Because if I don't know what I'm doing, how am I going to know it's correct? Looks like we have mixed numbers here. And essentially, these quantities are all the same. We're adding here, so we're adding mixed numbers here. We're multiplying the mixed numbers here, dividing and subtracting. But let's just let's look at A. By the way, for everyone that's at home watching this, A is the correct answer. Let's study A and examine why A is correct. First, I'm adding 2 3/4 plus 3 1/3. How do you do that? One way is to set it up like this. 2 3/4 plus 3 1/3. I'm going to add this like in a regular addition problem, but I'm going to add the wholes first, and I'm going to get 2 plus 3 is 5. I'm going to add the fractions. I'm going to separate, the addition of these right here. And this one here is going to require, when you're adding fractions, you got to make sure that before adding them, you got to make sure that you convert them into fractions with common denominators. So let's see. I can't subtract the 3/4. I can't subtract 1/3 from 3/4 because they have the denominator is not the same. So I want to find a denominator that 4 and 3 both go into. One easy way to do that is just to do 3 times 4 and you get 12. Now how many times does 3 go into 12? 3 goes into 12 4 times. So I could do 3 times 4 gets 12, and I would do 1 times 4 gets 4. And that's my bridge, really. 3 times 4 is 12. 1 times 4 is 4. What's the bridge for this one? Let's do another color. 4 times 3 is 12, so I do the same thing to the top. 3 times 3 is 9. So now I could add 9/12 and 4/12. Did I do that right? Okay. Now I would add those together and I would get something like 13/12. Now 13/12 we could think of as 12/12 plus 1/12 would get you 13/12. And this would be a whole. There's your whole, and that would eventually get added to the 5. So the answer would be 6 and 1/12. Now look. Everything that I've done in the black is not a step that you need to do. But you do want to make sure you can review how to add fractions together by finding the common denominator and how to separate your whole numbers and your fractions so you can add mixed numbers together. And when you're adding mixed numbers, you always add the wholes, and then you also add the fractional part separately. And then whatever those answers are, in this case it was 5 plus 1 and 1/12, then you add those together to get to your answer. Alright, the same thing would work with subtraction. So D, everything is correct. You subtract the wholes, you subtract the fractional parts. The only thing that's wrong is even after you do the subtractional portion, what you're going to have to do is then add what these two quantities are. So this should have been a plus sign. Everything that I've just done is really tricky. And if you're stuck at any of the points of adding fractions with unlike denominators or adding mixed numbers with unlike denominators, if you're stuck with that skill, and the flip side of that is subtracting fractions and subtracting mixed numbers. If you're stuck with that, it's good to take note and go back and review how to add and subtract fractions, because that's the core skill behind A and D. And that's actually the first level before multiplying fractions out. Now, multiplying fractions and dividing fractions. What you need to know is that you're not going to be, when you do that, you have to think of this as one whole unit times one whole unit. So you wouldn't be separating your wholes and your fractions here. You'd want to keep them together. Okay, team, I hope you found this helpful and insightful. Take care. Bye-bye. Hi team, I wanted to encourage everyone, if you have time, to check out one of the MTEL math workshops. This is a great time to make new connections in the math. It's 2 days, 1 or 2 day workshop. You can go to GOHmath and find out more information. Take care. Bye-bye.